today's video, we're gonna dive deep into quadratic equations. So can we just dive right in? So first of all, what is a quadratic equation? Equation with highest power, that is degree. Okay, two. Oh, okay. So the degree has two, right? So this is what a quadratic equation is. So let's look at a few examples. X plus 2 equals 5. Is it a quadratic equation? No, because the degree is 1. Degree equals 1. And then x squared plus x plus 2 equals minus 3. Okay, minus 2. Is this quadratic equation? Yes, degree equals 2. So degree equals 2. Okay, and then we also have this x squared minus 3 equals 0. Yes, same implies here too, right? So this is also a quadratic equation. Okay, so now let's get to some examples. Let's say x squared plus x minus 4 equals 0. How do you find the roots? There's a formula. Let's see, if the equation is ax squared plus bx plus c equals 0, then x equals minus b plus or minus the square root of b squared minus 4ac by 2a. Okay, so in here, uh, okay, sorry. Here you just plug in the values. Here in this equation, a is equal to 1, b is equal to 1, c is equal to minus 4. So x equals minus 1 plus or minus the square root of 1 plus 16 by 2. It's minus 1 plus or minus the square root of 17 by 2. So x equals the oh, I'll write it in blue this time. So x equals the square root of 17 minus 1 comma uh okay, that's minus of the square root of 17 plus 1. So it means that these are the roots. These two are the roots of the equation. That is, if you plug in the values here in the equation, if you plug in either the square root of 17 minus 1 or minus of the square root of 17 plus 1, you'll get the final result will be 0. Okay? So now that is the entire idea. Okay. Now let's say we got roots of an equation as minus 2 and 3. They're asking us to like using I'm not that strong in factorization, so I just usually use a trick to show that I'm good at factorization. Okay, even though you're not good, you can just show them that you're good by just knowing the formula, okay? So first use the formula. So for example, using the formula, we get minus 3 and 4 as roots, okay? They're asking us to factorize it. Now, if you look at this, x equals minus 3 is one case, and x equals 4 is another case, right? So x plus 3 equals 0, x minus 4 equals 0. So you just split it. Now you don't do it in the main descriptive part. You do it in the rough column where teachers usually don't see that. Even if they do, they can't reduce your marks because you did it in rough column. That's only for you, right? So the final result must be 0. So 0 into 0 is equal to 0, right? So now that's the key idea. So you'll get x plus 3 into x minus 4 equals 0. Because both of these are 0, right? So the whole thing will be 0. But you shouldn't directly show them because they look for the step. Now you're still in the rough column. Even until this, you're still in the rough column, okay? So now you multiply this x squared plus 3x minus 4x minus 12 equals 0. Okay, so now you get back to the main column, okay? Now you tell them that you write the equation first of all, x squared minus x minus 12 equals 0. They'll most probably give you the equation, okay? So no worries, equals 0. So now you show them that x squared plus 3x minus 4x minus 12 equals 0. So you take x common here, x plus 3 minus 4 common here, 4 into x plus 3 equals 0. So x minus 4 into x plus 3 equals 0. So now this is the final result you get. So now you say x minus 4 equals 0 and x plus 3 equals 0. So finally x equals 4, x equals minus 3, x equals 4 comma minus 3, and that's it. You're good to go, right? Okay, let's do some more. Come on, let's do it fast. Do I have to add some page or something? Okay, fine, no issues. SAT math. Okay, now let's say well, let's take the same equation, x squared minus x plus 12 equals 0. Okay, okay, let's say this. We have this, so I think it's minus 3 and 4. Okay, 3 squared plus yeah, that's true. And then what if it's 416 minus 4? Yeah, true. So this is the equation we've got. They're asking the product of the roots. Many people will find the roots minus 3 comma 4, but you don't have to find the roots actually. I'll show you how. So sum of roots, okay, this is equal to minus b by a. So which is equal to minus of minus 1 by 1, which is equal to 1. So this, if you cross verify this, minus 3 plus 4 equals 1. Okay, so this formula works. This is the fastest method you can use. Okay, so and you have product of roots. Most of the people get stuck in this problem. They find the roots. They spend a lot of time in this question, but you don't need to. You just have this formula. Okay, product of root equals c by a. Now c is minus 12, right? So this is minus 12 by 1 equals minus 12. Okay, Now let's just check it out. Minus 3 into 4 equals minus 12. Both are equal, right? So that's how you find the sum and the product. So I guess it's pretty easy for you until now. Okay, so shall we continue? Okay, so there's something called discriminant, which is b squared minus 4ac, which is the thing inside the root of this. So if it's greater than 0, the roots are real and distinct. If it's equal to 0, real and equal. If it's less than 0, it's imaginary. I'll show you how. Don't worry. So let's say it's greater than 0 means that's b minus b plus or minus something. If it's plus, you'll have a different value. If it's minus, you'll have a different value. Whereas if this is 0, that's just minus b by 2a because this is completely cancels out, right? So that's minus b by 2a, which is one certain value for x, okay? And then it's imaginary if this is less than 0. The square root can be less than 0, okay? Let's say you have the square root of, okay, let's say the square root of minus 17. So delta equals, let's say, huh? Then delta equals 17i. I equals the square root of minus 1. This is a formula, but you know, it's just imaginary. I is imaginary because minus the square root of 1 is never been possible or plausible. Okay, so like that you can find this. So let me show you one cool trick to you. If you're writing the SAT test, Desmos, a graphing calculator, is completely allowed. Great news. We can use it like anything, okay? Now, the roots are nothing but the x coordinates of the points where the graph intersects the x-axis. That's just like the zero of a polynomial I've taught before, okay? So now the root of the equation is minus 3 and 2, okay? So now this is pretty cool, right? You can just use the Desmos and find the roots. And we'll also do this one, minus x, minus 12, this one, right? So let's check out the roots. Minus 3 and 4, that's it. You don't have to spend that much time in here. You can just, you know, write the equation in here and the Desmos calculator will manage the other stuff. So we have this, and then what else do we have? We saw about the nature of roots and many more. Okay, I guess, yeah, I have one more thing. Wait a minute. Okay, gotta hurry up. Video is already getting too long. Okay. So the vertex, okay, vertex, that is, okay, I'll explain. Equals minus b by 2a equals d by 4a. And, okay, you have something else I saw before last year, I saw something, some formula we have. Ah, yes, if a is positive, parabola is open. A is negative, closed. Don't ask me if a equals 0 because if a equals 0, the degree will become 1 and it will become a line linear. A parabola is only for a quadratic equation and it's always a parabola for a quadratic equation. Okay, so now let me teach this to you. Okay, d is nothing but the discriminant. You can even say delta. Okay, discriminant. Okay, so the vertex is nothing but, okay, let's say you have a graph like this, or else let me make it a little sharper for more accuracy. Okay, now this point, this this is the vertex, the end point of the parabola. This is the vertex, okay? And if the parabola is open, the graph will be something like this. And if it's closed, the graph will be something like this. So this is open, only see upwards, it's open upwards. It's just closed upwards, okay? So that's it for today, guys. Bye, see you tomorrow.